Okay, so for this video we're going to be looking at storm drain inlet design. This doesn't include the full storm drain design, so we're not looking at pipes capacity, we're just looking at inlet capacity and inlet protection. And again, for all my videos we'll be using or looking at hydroflow, and for this specific video you'll be looking at the inlet reports. If the engineer does not provide an inlet report in his hydroflow calculations, then that's something you can request as a plan reviewer. It's simply clicking on a button, and all this information should be provided in a report for them. So it's not hard information for them to provide, and it's something that absolutely has to be done in the design of the site. Alright, so the first thing to note is the inlet report doesn't show the area. It shows a flow rate that is input by the engineer, but it does not show an area. In South Carolina, DHEC recommends no more than 1 acre draining to a single inlet, but that's not shown on here. So one thing I typically request is to show the breakdown of how the flow rate is calculated, and I ask them for the C, the I, and the A, the area, and I make sure that no inlet has more than 1 acre going to it. Now that's just a recommendation from the SCDHEC, but that's not a specific design requirement that is listed in a specification or any type of ordinance. So the engineer, that's at his discretion to use areas over 1 acre, but as the plan reviewer you can point that out to them. Okay, so the next thing we're going to look at is just each row here. So the first row is just the flow rate. Okay, and I'm going to come back and talk about some things here as far as it relates to inlet protection. But the next line is Q carry. The next line is Q capture. The next line is Q bypass, so that's one you want to really look at. If there's any bypass flow, then that inlet's missing water that's coming to it and it's going down to the next inlet, so it should be a larger inlet if there's any bypass. Something really important to look at, and the next line is the junction type. If it's a manhole, the manholes will obviously be 0, they're not capturing anything. And there's also curb inlets and grade inlets that you'll see there. The height should always be 6 inches because the curb height is 6 inches. Now the length is something that's important. From what I understand, I could be wrong here, I've only done 3 or 4 actual designs using hydroflow, but the length, to my understanding, is automatically populated by hydroflow. So you want to make sure these links relate to what's actually used and what the details call for the curb inlets. Sometimes hydroflow will kick out links of 20 feet. It does use standard links, 4, 5, 12, 20, 15 of what's actually offered out there. But be very careful that these numbers are what's actually used, because they are automatically populated, so there is no bypass. That's an option with the design. Okay, these next 3 lines are just more dimensions of the grade itself, not something if there's a grade inlet. And then you have some information about the gutter, and then some information about the inlet itself. And that's so the spread is kind of how big the pool is around the inlet for that storm, and the depth is how deep the water pulls up at that inlet. So something that I usually check here is to make sure any of these inlet depths do not go over 6 inches, because if it's over 6 inches, then it's overtopping the curb, is what the model is showing there. So that's another thing you'll want to check. And backing up to the Q carry, Q capture, and Q bypass, these 3 lines, if it's something you want to know more about, there's a lot of information online you can simply go to Google, type in HydroFlow Storm Sewer Manual, and this document will pop up. It's something that's very useful for me when I'm doing stormwater plan reviews, especially for the storm drain calculations. But this little image describes the Q carry, the Q capture, Q bypass. And similar, this image here shows the dimensions for the length, the gutter, the opening, the throat. The dimensions that you see in the chart are represented in these different images in the manual. Okay, so now going back to this flow rate, I said I had something at the beginning of the video. This is where I always check that the inlet protection is sufficient. And this is one of the most important parts of this video. In South Carolina, DHEC has a design manual that lists that certain types of inlet protection should be used for certain flow rates. So now looking at DHEC's Stormwater Design Manual, and you'll see the different requirements for the different inlet types. So type A is essentially just the silt fence or sediment tube. So those should be up to 1 CFS. Type B, which is your wire and gravel inlet protection, they can stand up to 3 CFS. Type C is similar to Type B but uses the blocks, and that's also 3 CFS. But Type D are the manufactured products like silt savers and those type of products, and those can be used for velocities greater than 3 CFS, and you would use those based on what the manufacturer provides for the allowable flow rates. So going back to the calculations now, you'll see that there are some flow rates over 3 CFS, and those would require the Type D inlet protection. And of course you would want those to be noted on the plans where those are required, and have a different symbol for those and a call out note so the contractor does not miss that. That's something that can be commonly overlooked. They'll just go out there and try to put in the same inlet protection for all inlets if that's not clearly called out in the plans.